Good morning, everybody. I hope everybody is doing hunky-dory today. We are going today do this little lecture review about coal. So this is lecture two for the class in the wonderful world of coal. We're going to go through coal today, and then later this week I'll start talking about natural gas, and then we'll start getting into oil, and I'll finish the fossil fuel section for this class here on that energy use. But in this lecture, will help you understand the historical importance of coal, its formation, extraction, and uses. Also, we'll talk about coal's energy advantages and disadvantages, and some of the environmental, political, social, and economic impacts of the coal use over time. Um, because coal has a very, very interesting history. All right, it has been around for decades. We've been using coal since we found it laying there on the ground and started burning it. Okay, and combining its stored energy with the steam engine is highly noted as one of the most pivotal points in the industrial revolution, not revelation, but revolution, in where we are today. It was because we were able to harness all that energy that was stored in that old biomass over those millions of years, and it turned into a nice little French wine for us. And we were able to move that steam engine, and boom, we were off to the races, man. We really started knowing how to harness more and more energy, and that coal was really a bang for its buck. And if you even look back at some of the Leonardo da Vinci engineering drawings and stuff, it was us being able to harness that energy of coal that led to a lot of those inventions. He actually invented a lot of these things that we have today. It's just that he didn't have the fuel source to do it. But we have, through finding coal and also the oil, we've been able to do some of the things. He had one of this little robot this one time. It was like it was steam run. It was just like the steam engine, but he had to use like a candle, so it didn't work too well. All right, and not enough bang for a buck. Now we throw coal in the same thing Leonardo da Vinci made and turn it into a big old train, and we're putting railroad tracks all over the place. So coal is definitely a pivotal thing in our development throughout humanity. And it's really just a short blip, all things considered. But coal is basically just a hard blackened substance formed from woody organic matter, compressed, dense, solid carbon structure. All right, so we're going after those carbon chains within inside the coal, and that is just old, ancient wood matter. All right, and it's just been compressed and uh, turned around by the earth over millions of years and turned into this nice, great French wine that burns a great BTU. Right? And there's different kinds of coal. There's surface coal, which is primarily extracted through strip mining, and subsurface mining evacuates through large tunnels. We'll talk about those in a little bit. And then we'll also talk about the Appalachian Mountains, how they were just ripping off the whole uh, mountaintop to get to this coal. All right. But coal basically was just formed millions of years ago from these old swamps when the dinosaurs were roaming and all this organic matter. So the sunlight came down, right, and the magic of the plants uses that photosynthesis and converted that light energy into chemical stored energy into its carbon into its trunks. All right, and a lot of that stored energy um, was carbon. And that carbon, those plants finally died off and fell down into the peat in the swamp, and they were unable to get back. That carbon was unable to enter that carbon cycle through the, um, through respiration of them being decayed like they would normally do, and it was trapped underneath all the swamp water and slowly layered over by dirt. All right, and as time went on, the millions of years went on, the tectonic plates moved this land mass and started burying this, squeezing out all the water out of the old carbon, old organic matter, and pressing it down and heating it up and turning it into what's called lignite, and then finally into what we have now today, which is a good, fine, burning coal. And this process takes millions and millions of years. And we cannot reproduce this because of the pressure created by the earth. We are not able to replicate that today. So it's, it will be renewed someday. There's a tree that fell down in the woods somewhere today that will turn into a lump of coal, I'm sure. All right, but we won't be able to find that out to millions of years ago. So when we're looking at coal and all these fossil fuels, just remember that coal was just ancient sunlight that magically transformed and stored into usable energy for us to utilize a million years later. All right. The plants provided it all. The primary producers provided it all for us. So the types of coal. All right. So we got coal from the original part, the swampy thing comes from what we call peat today. All right, and not just the undecayed uh, biomass from the trees and the leaves and the grasses and all that other rigmarole that's left in that partially bottom of the swamps and bogs. All right, and there's a low heat content, so it doesn't really decay all the way. And then later on, what happens is it turns into what's called brown coal or lignite coal. All right, and then it has a low heat content, so it doesn't burn as well. All right, but it has a low sulfur content and it's limited supply in most of the area. So we don't use this as much. All right, but what we do use most is a lot of bitterness soft coal. All right, and it's used as a fuel because it has a high key content, high BTU. All right, found in a large supplies and normally has a high sulfur content. So we're going to talk about the sulfur content, what causes some of that acid rain problem. It's in one of your readings we talked about. All right. So our use of coal actually helps spur some of that sulfur rain. But today we don't really have that acid rain. We've been able to control that, which is good news. Um, and then the one that we use for the big stuff, the arsenic, um, hard coal. All right, and this is the highly desirable coal because it's has a high heat content, low sulfur content, so you don't have to spend the money trying to get that sulfur out before it enters the air or the water. And the supplies are limited in most areas because this is a very rare. I shouldn't say rare, but it's the one stuff that's really been formed over those millions of years, and there's only a couple of big deposits of those, and it's a little bit harder to get to. Some of it's not even technologically recoverable. All right. But each fossil fuel has its own mix of energy uses, right? But today, coal is primarily used for us for generating electricity, right? And we use what's called a coal-fired plant, where the coal is just converted into water or steam and turns a turbine to produce the electricity. And this is the basic setup for a coal-fired plant. This is also basic setup for a nuclear plant, and sound kind of like a turbine almost, all right? But what we have is here's the fuel source. So this could be coal, this could be wood, this could be wood mass, all right? But we're using coal in this situation. And it goes into the bunker and it gets pulverized and mixed and milled so it gets real fine. And we just burn it, all right, in a furnace. So we're converting the old organic carbon compounds, lighting them on fire and taking that carbon and turning it into heat, right? And that heat only boils water, makes a steam engine, right? So it boils out water, and we take that steam, right, and we kind of put it through a little hose and condense it down so it jets across these what are called turbines, right, and that causes the spinning action, right, which spins a generator, and inside of here are some magnets and some electricity that we all learned about how to make electricity with electromagnets and the magnets spin around its electricity or these copper wires, and out comes the electricity, right? And remember, this feedstock for any basic electrical plant. As long as we're boiling water, this could be the coal going in. This could be, like I said, wood pellets or some kind of biofuel, or it could be a nuclear power plant that's boiling the water. All right, as long as we're boiling the water and turning this turbine. Okay, and then it also cools down. It's important also to note that most of this stuff that you see today at the coal-fired plants, and you see that cooling tower, you see all that white smoke coming out. That is actually the steam, all right, from the water condensing. Most of the pollutants today for the coal-fire industry are actually filtered and taken out and put in these vacuum bags and stuff like that. It's one of the dirtiest jobs is trying to keep this plant clean and getting these filters. I went on a tour one time of a coal plant, and I saw those bags, man. That must be tough. All right. And then there's also a lot of ash too left over, depending on your biomass that you're using. All right. Whether that's coal or wood or whatever, you're still going to have that ash to be able to deliver out. So you got the toxic chemicals that have been moving around in that coal for millions of years, and also the ash here um, for the to be hauled away. All right. But before we started using coal for a lot of electricity, believe it or not, coal was used to heat our homes, and it's a great case study to look at of how we went from in 1940, where we had about 55% of the homes in America heated by coal. Right, you can still find a lot of coal chutes and a lot of homes around here in Pittsburgh area where they come and deliver your coal and you put it in your coal furnace. All right. But we didn't like that too much because it was kind of dirty and smelly and took a lot of work and stuff like that. And luckily, we built the grid, all right, the electrical grid. So a lot of the coal was moved out to heat our homes, and we just started using electricity in the homes, or we started to pipe it in. You can see here is utility gas, so the natural gas. The next section we'll talk about started taking over coal for heating our homes, all right. And today we'll see in the business section or the competitive section for electricity, it seems like natural gas is really one of the biggest competitors to coal for making that electricity. That is due to it has a lower carbon emissions when it's being burned to boil that water to make the steam to turn that turbine, which has those magnets, a couple of wires making that electricity for us. Okay. So it's pretty neat case study to see how we switched from heating our homes with coal, going to electricity, all right, and then natural gas coming to heat our homes, then going to electricity for coal, and how natural gas is actually switching in there to make our electricity as well. All right. Personally, I hope both of them don't work or don't win the day. I want have 80% renewables and 20% fossil fuels. And we're not on that path. All we're doing is going from coal to natural gas right now in the energy section. Okay. But there's also other uses for coal than just boiling water to make some steam that turns to turbines to make electricity and heat in our homes. It's very actually, the cement plants and the steel manufacturing don't get overlooked a lot in the coal industry. All right. When I realize that we'll never get rid of fossil fuels. It's like an impossibility because they do have a unique purpose, and steel manufacturing and cement plants is definitely a unique purpose, and it's kind of helpful, right? I think we can make electricity a lot of other ways, all right, but there's not as many ways to get the needed BTUs, the energy transfer, to make this cement and manufacture and steel. So that's why coal is really important. Right? It gives us an excellent bang for our buck when it comes to the energy output. Okay. Coal can also, believe it or not, can be liquefied to run our cars. Right? So we take the feedback of coal and we have to actually add some water to it because it's so dry. All right. And we put it into what's called a gasification that creates the raw gas. All right. And it's cleaned up the sulfur and some of the CO2 is removed. And that turns into a gaseous state. All right. A syngas, which is then converted into a methanol. All right. And that methanol could be put right into our gasoline, into our car engines, and we're off to the races. All right. And there's some separate processes that happen throughout this. And this process has been known for a long, long time, believe it or not. The inventors of this were the Germans during World War II. They one of the easiest ways to win a battle is to get rid of your enemy's energy sources. So no one would sell Germany any diesel fuel to run their war machine on. All right, so they started doing coal liquefaction, it's kind of like the term for it, and they started making coal into gasoline. All right, and I had this little diagram down here, just for a little FYI, and later on, in this class, we'll learn about biofuels. All right, how we take plant matter like switchgrass or corn, and we make it into an ethanol. All right, a biodiesel or something. And guess what? This process, same as this process. All right, except the organic matter that's going in here is coal, and the organic matter is going into here is wood chips or cellulose or whatever. All right, but the process is still the same. We're converting one carbon chain into another storage place so we can put it into a liquid and use it later in our cars. Okay, this process is very dirty though, and that's why it really hasn't caught on. When I was at WVU, we worked with China to build a big plant. I don't know if they ever got it built. I know they were building it. I don't know what function it is now. Those are during the good old days. Um, but I know that we've tried, but it's very very dirty and it's a expensive, very expensive product. All right, so you're gonna get like this is America. Let me see a good price comparison. This would be about $8 a gallon when our gas is about $3 a gallon. All right, maybe even more. All right, because you can see all the different inputs that happens with inside of here. Coal's energy return on investment, EROI. All right, it has relatively been kind of stable throughout time. So remember, that's how many energy units do we get out for every energy unit we put in. All right. So we're back in 1920s, we'll get 50 to 1. The best kind of stuff, we're up to about 81. And today, we're about 75 to 1, 60 to 1, somewhere in there on energy return and investment. So it's very good bang for our buck, all things considered. Just give things into perspective here, we can see that oil production, right, you're only getting like a 40 to 1, right, where our coal is way out here. Okay. So it definitely is giving us a great bang for our buck, and it will never go away, right? And this great bang for the buck is what makes us able to do the steel and the cement and stuff like that, all right, because it has the potential BTU units to do this efficiently. Okay, so we'll never really go away, but it does have its drawbacks, most certainly. Okay, coal mining jobs over time have, I like to hear the saying. I don't know if you guys ever heard it. They say it's the war on coal or whatever. All right, and we can see here that yes, the coal jobs have declined over time. All right, so this is from the BLS, Bureau of Labor Statistics. Okay, and the different presidents, and you don't have to mind the presidents. Just you can see the coal production going down, kind of flatten out here, and then lower out here. All right, now these are coal mining jobs. All right, but you can see adversely. All right, so 1985 would be right about here. Right, you can see. Oh, go back here. You can see since 1985, you can see the production of coal has gone up and up and up and up. And then this sudden drop here. All right. This is great during the Great Recession areas. All right. And the competition of natural gas entering the field for electricity. Okay. But you can see it correlates too with these jobs going down here. So there is some correlation of how some of the coal production is dropping, and the jobs are also dropping too. But it seemed to have leveled out. But it's not as dramatic as these two, I don't think. Okay. But the reason why the jobs aren't necessarily sticking around is not because that there's more competition or less production or whatever like that. It's some of the jobs are no longer made for humans. All right. Our technology has provided several techniques for us to get out this coal. So the old days we used to put down the shaft, and you had the miners down in here with the old railroad tracks and donkeys, and pickaxes and shovels, right? But today now we got these big old machines that can just go around right into find the coal bed. We dig down right where the coal seam is, right, and just get this big old rig, and one person needs to do it. It just chips away at all this coal bed, and we just take the coal up and boom. Okay. We do it also like on a slope mine or a drift mine as well. Right. So there's no real old manual labor in coal mining per se. All right. To get these, we also have surface mining that is used too. We use these big, huge drag lines, known as drag lines. And some guy doesn't even like He sits here in this little thing in like a air conditioned room in some office in Seattle, and he can control this mine, this rig in West Virginia, like he's playing a video game. And this thing just scoops out the side of the hill and just keeps on scooping it out. And when it gets to the coal, it takes that out a little more carefully and ships it out. All right, but they're just basically just taking rock, more rock, and taking out the whole section. All right, and we can also cut right through the coal beds, whatever. But the most, wonderful way we have for extracting uh, coal today is what's called mountaintop removal. All right. So we no longer, like I said, put the people down there and with the pickaxe and shovels. We just basically blow up the top of the mountain. Okay. And push off all the debris to the side, get to the coal seam, suck up the coal, and then come back here and put some topsoil down, plant some trees, and maybe we'll put an RDC park up here, or a new shopping mall, or maybe a Disneyland, or what have you. All right, but we basically just blow up the mountain. All right, and this produces a huge amount of rock and soil erosion. There's a lot of problems that go along with the harvesting of coal. Um, we have this thing in America which is called the now I can't remember the name. There's a list where the most polluted sites in the world are. All right, or we're trying to fix them up. And I know I'll remember this name after I'm done with this PowerPoint presentation. The Superfund Act, that's what it's called. We have the Superfund Act, and all these environmental damages place. So we used to do some mining, some coal mining, gold mining, and things like that. And there's most of the things on the Superfund site that we can't really figure out how to clean up yet, and no one knows who's responsible because the business has gone out of business and just left up to us to clean up the mess. All right. Um, Most of those sites are actually coal mines. All right. There's one coal mine here in Pennsylvania. Feel a little adventurous, go into Google and Google coal mine on fire in Pennsylvania. And it'll take you to this little coal mine that has been on fire for like 20 years. All right. A whole town had to evacuate and the town's been a ghost town forever. All right. So they can't put out the fire because there's so much methane and coal in there just burning and burning and burning. It's crazy. So and that's one of those super fun fights. So we don't know how to clean it up. We can't put out the fire, and it just spewing out toxins. Okay. But one of the biggest problems we have with coal, besides all the environmental damage that we can actually see, the other one is really the carbon dioxide. And that's the one we really have to try to fight with today. Because we've done a good job controlling us off of the sulfuric acid and the lead and the canadium and all those kind of toxins that are found in coal. We really have. I mean, it's not really as dirty as people think because we have the regulations that keep us safe. We get into those filter bags. Now, what we do with those filter bags after we catch all that stuff, that's a different story. All right. But we are able to contain that stuff and not let it get into the environment as bad as we used to. All right. We have what's called generally considered safe levels. And most of the power plants are doing the generally considered safe levels. And that, what I mean by that is how much lead you're allowed to have in your body so you don't get mentally ill. All right, or how much Canadian can you intake? All right, we always get a little bit of radioactive from the sun. There's always these little limits. All right, and corporations have been regulated to stay within inside those levels. And I think it's worked very well. It's something we should be very proud of here in America and around the world. All right, we still have electricity. It's still nice and cheap, and no one even realizes, that we don't have that lead poisoning that we used to have, and all that other stuff that used to come along in the beginning when we were just burning this stuff in our furnaces in the 1950s like it was going out of style. All right. So we've done a lot to clean it up, but the clean coal technology doesn't really refer to um, all those chemical contaminants. It's more about trying to get capturing the CO2 in the atmosphere. All right. And that's the last thing we really need to do um, to grab that. And we'll talk about carbon sequestration at the very end of this. Okay. But the coal impacts of the environment are pretty grave. We've seen them over time. But we have done a better job of it. All right. And some things we can't do. All right, is the land and ecosystem disturbance from mining. So it's very extensive on the surface and in on or underground. So we do damage the surface to get it out, and that just pop. That's all part of the throughput process, right? We have to do the same thing if we're harvesting iron ore to get the steel for the wind turbines, or the carbon fiber for the wind turbines, or the silicon for for the photovoltaic cell. So we got to remember that every energy form has a ecological footprint, and coal seems to be the highest when we look at them. And you know, that's my humble opinion, but nuclear could be there too. Okay. Greenhouse emissions is probably the hardest ones. All right, that has considerable emissions. It's one of the leading contributors to greenhouse emissions. All right, putting those little balloons of CO2 out into the atmosphere, which trap more latent sun. That's the one that latent heat from the sun. So that is one of the things we are trying to overcome today in society, and the hardest one for us to overcome. But I think we have a blueprint for that. If we look at what we did with the acid rain problem, we use the same techniques that we did to solve that problem. We could solve this problem, the CO2 emissions, with our fossil fuels. I firmly believe it, and it worked. It worked real well. All right, it wasn't perfect, but it did work. There's other pollutants besides the greenhouse gas emissions of sulfur dioxide, nitrogen oxide, particulate matter, and all these other things. And I think we've done a real great job of keeping this together for the um, coal industry. All right. Yes, people complained and said it was going to ruin jobs and all this stuff, but none of that stuff happened. We're actually better off, and we got a lot more positive externalities from putting these controls in. People aren't getting sick, my friends, and we still got pretty relatively cheap electricity, very cheap electricity. Um, there's also occupational health among workers. All right, more health problems at the facilities with our coal workers. All right, it's not as bad as it was, when we used to do a lot of the coal mining and sending the people down to the pits, but it's still a very dangerous job. All right, health impacts of nearby residents when we're not only mining and getting, putting the debris up into the air, but also when we're burning it in the coal fire plants and things like that. So the air pollution, definitely there's what's called cancer alleys, right? So if you're living around a power plant that is a coal fire plant, or even a active mine, people living around those health areas seem to have more health impacts. All right. There's not too much consequence or accidents of sabotage out there. It's not really, you think of a nuclear power plant, it would be very easy to get blow that up or whatever. There's no really threat to our coal industry. Uh, market price effects, and what I mean by this is there's known economic impacts of being around a coal fire plant or a mine. Typically, that will lower the value of a homeowners, and there's not as big as a employment base except for that mine around there. So it's not as active as a lot of people think. When there's clusters around a coal fire plant or a mine, the economics impact is not as great as most people would think. There's no radioactive waste from it, which is a good thing. And fuel supplies remain. We should have several hundred years of coal left, so we'll never get rid of coal. It'll always be around with us, and it's a very important fuel source because we get like I said, we get a great bang for our buck, right? But the emissions, like I said, poses health risk and drives climate change. And this is what we're trying to work on the most in society today is climate change. We've really confronted this health risk because no one really wants to get cancer, right? And we could kind of weigh seduce you a little bit more to help prevent getting cancer. But we don't really see climate change, right? We don't really feel it. It's not really with us. I think it's with us today, and I think we're seeing it today, and we're feeling it today. But way back when, we didn't really care about it, right? Yeah, it's 50 years down the line. Who cares? But here we are, 50 years from now, and we're in some trouble, All right. And burning fossil fuels also alters that carbon cycle, like I talked about in the first chapter or first lecture, right? So that's what we're doing. We're just increasing the carbon in the atmosphere, part of the carbon cycle, and that increase in carbon in the atmosphere traps latent heat. It's just the laws of thermodynamics. There's no ands, ifs, or buts about it. We can't do anything about it except control how much we humanity excretes, right? And maybe we can try to suck some of that down too, and try to what's called sequester that carbon as well. And we're going to talk about that right after this slide. So carbon dioxide is the greatest greenhouse gas emissions and is recognized, and methane is also a potential gas. And methane also comes from released from coal mines as well. We'll talk about that when we get into the natural gas section. All right, but you can see here for the CO2 emissions, here's a total from the Earth, from the world. So this is a total fossil fuel CO2 emissions, and you can see that coal is here leading the top of the spread, but it was kind of close with oil, right? So it's oil and coal both are competitive when it comes to bleeding out CO2. But you can see we've been using coal a lot longer, right? And it starts out about here, right? 1920s. Oops, 1920s. We started adding about 1 billion metric tons of carbon per year, and now we're up to 4 billion metric tons per carbon per year in our coal consumption. This is worldwide, okay? And you can see how natural gas is slowly creeping up here, all right, for its emissions, okay? And it wants to replace coal, but the line is still positive, okay? So can we capture and store carbon? That's been the biggest question in the coal industry today. It's probably one of the hardest hurdles for them to overcome. And what they're trying to do is capture the carbon capture as the store remains to unproven to be viable strategies. Let me say that one more time. Carbon capture and storage remains too unproven to be a viable strategy right now. And what they're trying to do is they take this power plant, the CO2, right? And instead of letting the CO2 just go out there into the atmosphere, all right, they'll take it and try to, first you see right here with this pump, they just take it down into a deep saline aquifer or whatever, something close to the power plant or wherever they're at. And instead of spitting out the fumes, they take it and pipe it and probably put it down in the saline aquifer and they don't come back, right? Or they can just go and try to put it into an old abandoned coal seam. And there's a lot of them around. We have the coal right here, and we got the coal out, and now we have nothing. Might as well throw the CO2 down there and try to forget that it's there, right? And say, don't come back. The most cost-efficient way to do the CO2 is they pump it and they take it to like an old oil rig, right? And just think about this as being, a glass, a milkshake glass, and there's a lot of chocolate milkshake stuck to the sides of the glass. So they'll take the CO2 and they put it under some pressure, and they put it into this hole, and that kind of forces all the milkshake, all the oil down here into the bottom, right? And hence they're able to suck up whatever left, recover whatever they couldn't get out, all right? And then close it up and say don't come back and take the profits and start burning this oil over here. All right, but carbon sequestration really hasn't been proven to be too advantageous. All right, during the last Obama era, he started a clean coal plant as part of the stimulus package or what have you, right? And that ended up being a bummer, all right, no pun intended. There was a lot of cost overruns for the plant. It was very expensive to do this. They didn't have any oil recovery to help pay for anything when they were doing this one plant, and it just went downhill, and they ended up stopping paying for it. Okay, so when you hear carbon sequestration, it's not really something that we're doing today. But I say go ahead, keep on working on it. All right, we've got to do something. All right, we either got to stop burning it or find some way to put that carbon back down in the ground and not let it back out in the atmosphere. Okay, and so we need some smart engineers to figure that out. because we just haven't been able to make it economically viable. So, in conclusion, coal is just ancient sunlight. That's exactly what it is. It's all biomass from our primary producers that give us all our other energy that we use. So, if it wasn't for the sun, and then the plant's magical ability of photosynthesis to take that sunlight and convert it into chemical energy and store it into their trunks and their good tasting vegetables and stuff like that, um, we would not be here. Okay, so coal is just that old stuff fermented into nice French wine that had been tossed around and pressurized by the earth over these millions of years. Some of the best storage energy, coal is some of the best storage and stored energy um, for the buck. All right, it'll never go away. So we'll always need coal. All right, and it's very advantageous, like I said, for the production of steel and then making of cement. Those two things are kind of important. All right, doesn't mean when coal's we got to control our carbon emissions and things like that and pollutions, but doesn't mean that coal can't still be used. The environmental health consequences are grave, but technology has helped overcome these obstacles. Right, we've come a long way to clean up the environment. The last thing we have to do is to help with carbon sequestration, trying to do something with the carbon that we're putting out there into the atmosphere. Um, and that's the last thing, but it's also the hardest hurdle because we haven't been able to produce anything economically efficient to capture all that carbon and I'll put it into the atmosphere. But someday, maybe. I say keep on trying, just keep on trying. The physics sound good, but the economics just aren't good. Okay? All right, so that is it for the coal section. I'll probably do another section here for the natural gas section coming up pretty soon. All right, sometime this week. So check back often to face or to Blackboard, and I will be posting these for you. Okay. If you have any questions, don't forget to ask, and also remember your homework due on Wednesday for the EIA assignment and your paper due. And please watch that video about this week's homework. Okay, there's a video about this week's homework too if you haven't seen it. All right. We will see you soon, everybody.